Welcome everyone to another Kuta software worksheet tutorial. Today we're going to be solving equations containing fractions. This is a really big turning point for a lot of people. They get really caught up on the fractions with equations and it just becomes too much that they give up. And I'm here to explain kind of a process that makes it a lot easier in my opinion. So let's go ahead and start with number one. I'm going to kind of show you the traditional way to do this problem, and then second, I think the much easier way. Now, regardless of which method you choose, the first thing you're going to want to do with this problem is you see we have a mixed number. You do not want a mixed number when you're dealing with equations, so we need to change that from a mixed number to an improper fraction. So the way to do that is if you have 1 1/4, you take the denominator, multiply it by this number, because essentially 1/1 is the same thing as 4, and you're adding it to 1/4. Okay, so you do 4 times 1, and then add 4 times 1, which is 4, to the top, and you get 5/4. So no matter which way you do it, the 4 times 1 plus 1, or 4/4 plus 1/4, you get 5/4. So that's just a quick way, and that's a different video entirely if you're not sure on how to convert mixed numbers, but this is what you should do. So no matter which method you choose, you're going to have to do some what I call cleanup beforehand. Okay, so let's proceed from there. Now this is where we kind of branch off with like method 1. This is the traditional method that I'm not a big fan of, and then method 2 I'm going to get to in a second. I'll use green for that. So method 2 is my preferred method. So the first method, what people do is they convert this fraction here into a fraction that has a common denominator with 20/20. So what they'll do is they'll take 5/4 and 19/20, and they'll try to find a common fraction. They realize that 20 is a common denominator with both. So it's going to say 19/20 for him because you're just multiplying by 1/1. But for this guy, he needs to be multiplied by 5/5. So this becomes 25/20. So then we have 19/20 equals P minus 25/20. We have to do the opposite operation to get P alone. So then what they'll do is they'll add 25/20 to both sides, 25/20 to both sides, and they get, what is that? That is 34, 44/20 equals P. And they could simplify that, so that's not too bad to simplify. I think you divide both by 2, you get maybe 4. Yeah, you divide both by 4 and you get 11/5 equals P. So that's one method, okay? Method 2, in my opinion, is a little bit easier. Let's see if we get the same thing. Actually, I'm going to keep this blue just so you can see the difference in the methods. So I'll make that dark blue. And then 11/5. Now, method 2. This is my preferred method. And what you do here is you take 19/20, of course, 20, not 1, equals P minus, same thing. We had to do that first step where we put it into an improper fraction. Okay, but now what we're going to do is we're going to take one step and we're going to eliminate all the fractions. How do you do that? Well, you still need to have the same thought process when you're looking at the 20 and the 4. What is the least common denominator with those, okay? And what we're going to do is we are going to multiply both sides of the fraction by that number. So you have to go through the same thought process. Okay, what number do both 4 and 20 fit into? What are they both factors of? And they're both factors of 20. So we're going to multiply both sides by 20. Now, what happens when you do that? Well, you need to keep in mind, you're going to multiply this 20 times this. You're going to multiply the 20 times that to every term inside the parentheses, which is on both sides. Every term on both sides of the equal sign. So then we're going to have 19/20 times 20 equals 20 times P minus 5/4 times 20. You may be thinking, what the heck? This makes it way harder. It doesn't. Why? Well, the whole reason why we chose 20 is because it cancels out with that fraction. So now we have 19 equals 20p. It's going to become 20p minus, now what happens here? The 20 cancels with the 4, but we still have what left over? Well, 20 divided by 4 is 5, so we still have that 5. So now we have 5 times 5 here and the minus sign goes out in front. So we have 5 times 5, and that gives us 25. Now what do we do? Well, we're going to add 25 to both sides, and we get 44 equals 20p. Oops, I don't know why I changed colors here. I meant to have it all green. All right, then we divide by 20, and then we simplify. 44 over 20 equals p, and we simplify that, and we get 11 over 5. So we ended up getting the same answer. Let me go like this. Okay, I'm going to try change this to green. Okay, change this to green style. Let's go this light green, I guess. Okay, you get the same answer. So one, you have to really kind of work on adding fractions, which a lot of people don't like. So if you want to avoid adding fractions, this is the way to go. And yeah, so we can go ahead and apply this to some of these other problems. So let's go ahead and do, number 6 is a great example of when you'd want to use this. Okay, so for number 6, we can look here, and we're going to use method 2. Okay, with method 2, what you're going to do is you're going to multiply both sides by 4. Why? Because 4 is the denominator with both problems, with both fractions, all the fractions. You're looking at any fraction that's in the equation. 4 is the denominator, so what number goes into all the denominators? 4. So now we're going to distribute 4 to every term inside the equation. So we have 5 over 4 times 4 plus 4 times x equals 3 over 4 times 4. Now we're going to cancel, because when you multiply by 4 and divide by 4, it cancels, and that's the whole point. So now we have 5 plus 4x equals 3. Move this over to isolate the variable. 4x equals negative 2. Divide by 4, we get x equals negative 1 over 2. So I don't know about you, but this method saves you the need to worry about fractions, etc. And honestly, I think it saves you some time. It's a really good way to go. We'll go ahead and we'll try maybe a tougher one. Number 12 would kind of be a tougher one. This one, again, you just need to convert these first, and it's pretty simple. Let me go ahead and do this one first, and then end with number 12. So with number 11, the first thing you're going to do is you're going to convert it. So I do 8 times 7 to get negative, keep the negative out in front. 8 times 7 is 56, and then we're going to add 3. So we have 56 plus 3 over 8 equals negative 2m. That's going to be, let's see, keep it negative, 59, negative 59 over 8 equals negative 2m. I'm going to multiply everything to get rid of that fraction, so I'm going to multiply everything by 8. Why? Because we're going to have negative 59 over 8 times 8 equals negative 2m times 8. Those cancel, left with negative 59 equals negative 16m. Divide both sides by negative 16, and we get positive 59 over 16 equals m. Okay, so that's one way to do that quickly. This one also is pretty quick. We see that we have 7 and 77 as denominators, so we want something that eliminates both of those. We're going to multiply both of all the terms, not just both the fractions, but all the terms by 77. So we have 77x minus, well, if we have the 4 over 7, sorry, I'm going to do this up here so you can see what I'm doing in my head here. 4 over 7 times 77, it cancels with the 7, and it gives 11 left over. So then we have 4 times 11, and then the 77 with this one, 12 over 77, it cancels times 77, sorry. It cancels completely, and you're left with 12. So then we have 77x minus 44 equals 12. We add 44 to both sides. Okay, and we get 77x equals 66. Divide by 77, divided by 77 to isolate the x, so we do the opposite operation. We get x equals 66 over 77. You can divide both those by 11, divide by 11, divide by 11 to reduce, so you get x equals 6 over 7. In my opinion, that's a much better way to go. I hope this clears it up on the best practice for dealing with these fractions. Feel free to rewind, go back, play it slow, pause it, whatever you need to understand this, and I look forward to seeing you next time on West Explains Best. Thanks for watching.